Okay, here comes the first lesson on Unit 11, which is about probability. And we're going to try to do this by flipped classroom. I think looking at the days we have left and looking at the lessons we have left and the timing and amount of material and all that kind of stuff and the way things have been going, I think we're going to try this next. So what's going to happen basically in the next few classes, or the rest of the year, is going to be you get the material this way the first time, primarily, kind of. This is your lesson with notes and things. And then when we get together synchronously in class, we'll be working on the part that used to be the homework. We'll be working on the problems. We'll be doing the problems together. But you'll always have this to refer to. You can always go back and watch this because it's on YouTube. You can go back and watch it slower and repeat stuff. And then when we get together, of course, it's time for questions. We might do more breakout room stuff, working in groups, and that kind of stuff. All right. So having said that, I think this one's going to be kind of long, so get comfortable. All right. So we are talking about probability. Probability is, you probably have dealt with some kinds of probabilities before in a previous class, but probability is this measurement of how likely something is to happen. And all your answers for probability, if you're doing it right, all your answers for probability should fall between 0 and 1. So there's going to be a lot of fractions involved. There's going to be a lot of dividing things and multiplying percents and stuff. And things should always come between 0 and 1. 0 meaning things are impossible. 1 meaning it's absolute certain. And you can see the scale in here in between. So 50-50 chance is like flipping a coin. We have no idea how it's going to turn out. And 1 is absolute certainty, and 0 is impossible. All right, so let's do some warm-up. Get your head around probability again. All right, what's the probability that the coin will land on heads? Well, we have two outcomes possible. We have heads and tails. Those are equally likely. One of the two equally likely, we're going to talk a lot about that later. One of the two equally likely outcomes is heads, so we can just say this. Spinner spun, what's the likelihood? Well, there's 8 equally likely outcomes if you look at the spinner closely. And how many of them have a 1 on that? Well, that would be 3 out of the 8. So that's really how probability starts off, and it's really not that hard. Okay. An experiment, there's some terminology here. In AP Stats, we get really technical about some of this terminology, but it's not that big a deal for vocab, especially for the level 2, level 3 assessment kind of stuff we're going to be doing in 2020 here in the online version. So experiment is a process for which an outcome cannot be predicted. An outcome is what actually happens. The sample space is the list of all possible things that can happen. So like heads and tails, that was the list. It's the list of outcomes, actually. See the word outcome here. And an event is a subset of the sample space. So sometimes, yeah, you'll talk about, well, what's the probability if we flip 3 coins, what's the probability that they all match? So an event could be something like that, where there's more than one way to successfully kind of achieve an event. So an event is like a group. It can be a group of outcomes sometimes. This is one or more possible outcomes. So when we're trying to find probabilities, it's usually probability of an event. And if all the outcomes are equally likely, it's just this simple fraction that we were just doing in the last page. Okay, so sometimes they're going to ask you to list the sample space. They don't do this a lot, but they do this here at the beginning to kind of get your head around, oh, I can do this quicker this way. Get your head around like what are even the possible things. So if you're rolling a die, here's your sample space. You just have to do this. List those as your sample space. That's it. Nothing fancy there. That's what the outcomes look like. Determine the probability. Sorry, I don't know if that's really small. If you can see that's 1, 2, 3, 4, 5, 6. That is the list of the sample space if you're just rolling this die one time. Determine the probability. Okay, so first of all, think about this. These 6 things are equally likely, so this isn't too bad. Find the probability that you're going to roll a 6. Well, that's one of those 6 things. That's all there is to that. Probability of 1 or 2. So think about how many ways could you get 1 or 2 successfully out of those 6. And here's the first time we got to talk about reducing fractions. Actually, in probability, and of course this does equal 1/3, and you can write 1/3. But what's kind of nice in probability in your answers, and they do this in the AP exam and stuff, is they accept, not only do they accept these kind of answers, I kind of like to see this because this tells me it's 2 of the 6 outcomes. This is completely fine. This is a correct answer. Some of you feel like I'm going to laugh at you if you leave it as 2/6. I've joked about that before. This is probably the best unit to leave it as 2/6. Also, they say this a lot in AP Stats. If you do this kind of arithmetic simplification, do some kind of really easy 4-function math simplification, and you make a mistake, they're going to grade this one. So you might as well leave it like this for 2 reasons. It communicates more about what the sample space was and how many outcomes met the event, and it doesn't open you up for making some other silly mistake later, so don't do that. Even number, I kind of can't help it though, right? Like, you know me, I can't look at this 3/6 and just feel a little bit funny, so I would take either one of these because 3 of the 6 are even. Not getting a 6, well, there's 5 ways to not get a 6 out of the 6 total ways. Notice these denominators all start out as 6 because we're talking about rolling the die. This is good to know first. Probability of getting a 7 looks like a trick question, and it kind of is. It's kind of silly to write 0 out of 6. You might as well say 0. But yeah, they do ask for impossible things. Impossible was part of the graphic on the first slide today. Probability of a number less than 10, also kind of silly because they're all less than 10, so you can just say that, or you can say 1. And you can think of 1 as equaling, like, basically, it equals 100%. Kind of talking fast here because I know this is going to be long. Okay, probability of red. All right, deck of 52 cards. So lots of times I'm just going to show you this picture. This picture is actually on the theorem sheet for the probability unit, because not everybody has a really good familiarity with the deck of cards. So this is all the deck of 52 cards laid out. There's no jokers. We're just talking about 52 cards. These rows are called suits. These are the 4 suits. Let me type this in here. Okay, so some card terminology. These different kind of symbols are called the different suits, and the suits are called clubs, spades, hearts, and diamonds. And yes, the hearts and diamonds are all red, and the clubs and spades are all black. And the ranks are kind of the columns here. The ranks are known as ace, 2, 3, 4, 5, up to 10, and then jack, queen, king. A lot of times you'll just see, oh gosh, and the other thing is I got to tell you what a face card is. Face cards, even though an ace has most of the words or letters of the word face, these are the only face cards. The face cards are down here. Sorry, this little pen is hard to write with. That small. Okay, 1 card is dealt at random. So basically you're choosing 1 card out of the 52. So first of all, think sample space. How many cards are in the sample space on these? And on probability, if you haven't caught this already, probability, it's almost always easier to think about the denominators in these fractions answers before you think about the numerator. So think about the denominator. So yeah, these are all going to be out of 52. Think about the denominator, and then all these, yeah, all the events they're going to ask about are going to be out of 52 when we're talking about 1 card. If it's 2 cards or 3 cards, or yeah, pick a hand of 5, it's different. But if 1 card out of 52, it's pretty simple here on the first lesson of probability. All right, probability the card is red. Well, that's 26. You might have guessed that would be half because it looks like half of the cards are red. But you can count them up, and yes, 26, these bottom 2 rows out of 52 are red. You can write that as that, or you can write this as this. Probability it's a spade. All right, so in the spade, you can kind of see that's one of the 4 rows, but if you're going to technically talk about the sample space being 52, you think, well, 13 of those cards, I put 13 total up here. 13 of those 52 cards, which, yes, is 1 out of 4. Those are all spades. Okay, whoops. That always happens when I try to make 4s on this tablet thing. Okay, black ace. So that means a black card that is an ace card, or black and ace. That is these 2 cards right here. So that's 2 out of the 52. Which is, you could also call that 1 out of 26. That doesn't have as much meaning here, I don't think, as some of those other fraction reductions we've done. Face card, okay, so the face cards are these cards over here that have the pictures on them of the people, the jack, queen, king. Ace is not a face card, even though it has lots of the same letters as the word ace. No, it's just these. So you count those up, there's going to be 12 of them. So 12 out of 52. Another way to think about that is that happens equally among each suit, and in each suit that's 3 out of 13, and that prevails throughout the whole deck. It's kind of fun. We'll talk about independence later. Diamond face card. Okay, so the diamonds are here. The face card diamonds are these 3. So this is just 3 out of 52, which sadly does not reduce. It looks like it ought to reduce, but it doesn't. The queen of spades is 1 particular card. She's right here. And she is only 1 particular thing out of 52. There's no other queen of spades. Okay. All right, fundamental counting principle. Yeah, it sounds like a big deal. It kind of is, I guess, but it's not that hard. For the experiments that have more than 1 stage, we calculate the total number of possible outcomes in the sample space by multiplying the number of outcomes. So if you're going to roll 2 dice, and think about how big is the sample space of rolling 2 dice or rolling the same die twice. There were 6, I'll say it right here, 2 dice. If you're going to roll 2 dice, well, you get to roll the die each time. You would think, well, there's 6 outcomes on the first die, and there are 6 outcomes on the second die, so there are a total of 36 outcomes. That kind of thing. Football team. So basically it means if you're going to do subsequent stages of an experiment, or one experiment followed by another experiment, you want to count the total number of possible outcomes you could go through all of that stuff, through both things, then you multiply. So yeah, so this is the most important word in the sentence here. This is when you multiply. Football team uniform consists of a jersey, pants, and socks. If there are 2 jerseys, 3 pants, and 2 socks, how can you do the whole uniform? Well, you got 2 choices for jersey, and, I'm also going to say and a lot here. And is a very important word in probability. and 3 choices for pants, and 2 choices for socks. If I do that correctly in my head, I get 12. What's the probability the uniform is all red? Okay, so out of those 12 choices, how many of them are all red? Well, we have one choice. We have to have the red jersey, and we have to have the red pants. There's one way to have red pants, and there's one way to have red socks. There's only one way out of the 12 to have red, red, red. 2 fair coins are tossed, one after another. How many outcomes are possible? Okay, well, there's 2 ways the first coin can be tossed. There's 2 outcomes it can have, and there's 2 outcomes in the second coin. That should be a total of 4 outcomes. Okay, list the sample space. Well, the first one could be heads, and the second one could be heads. You know, it'd be faster if I type it. Let me start over. And it'll be cleaner to read. All right, so the first one could be heads, the second one could be heads. The first one could have been heads. Why isn't this not letting me type? First one could be heads, followed by a tail. But the first one could have been tails, followed by a head, and the first one could have been tails, followed by another tail. Now, I know the first thing you're thinking is, wait a minute, 2 of those look the same. And they do look the same, but they're not the same. If you had 2 coins, think about this. If you had 2 coins that didn't look the same, now here the picture here is of 2 quarters that are, this is the front and back of the same coin, or it looks like the front and back of the same coin. If you had a quarter and a nickel, say, and you flip them, you could definitely tell the difference between these 2 outcomes. The fact that it's 2 identical coins or 2 different looking coins does not affect how many different ways this can actually happen. If you want to fight me on this, we can talk more about this in class. This is the beauty of flipped classroom. Oh, flipped classroom. There's a little bit of a pun here. Flipped classroom. It's already, the magic is already starting. Okay, great. Find the probability of exactly one tail. So first of all, I think this is probably easier to not have to fight about than this. I'm hoping we won't have to fight about any of it, but of course there should be 4 outcomes because of the fundamental counting principle we just went through. And so out of those 4, if we're thinking how many, what's the probability in a 2 fair coins situation? There's 4 in the sample space. There's your sample space. How many of them have exactly one tail? 2 of them do. So it turns out to be 1/2. I mean, once you believe this sample space, I don't think there's any fighting that might happen after that. It's this that we're going to fight about. But again, I hope we don't have to. It's not every year someone wants to fight me on that. Probability of 2 tails is only 1 of the 4 outcomes. It's the last one. And at least 1 tail is all but the first one. Right? The only way to fail that is to get 2 heads. All right, 2 dice. We talked about this before. This is actually the first example I talked about already, that 6 times 6 is going to end up being 36. That's a time symbol. It's really horrible. Okay, that's a big dot. Are each of these outcomes equally likely? It turns out that yes, they are. I'm not going to type out why. Because, first of all, we're going to talk about this later today, but about these 2 dice are what we call independent. Right, like so I have 6 equally likely choices on the first one. I have 6 equally likely choices on the second one. One of them doesn't affect the other. There's nothing that, after the first die turns out to be 4, like the second one doesn't have to be not 4 or anything. Like, there's no relationship there. So all 36 of these outcomes are equally likely. And here's the 36 outcomes we have. Let me type this in because this would be painful to watch me do it. Well, I guess I could start. This is like if the first die is 1 and the second die is 1. This is like if the first die is 1 and the second die is 2, etc. Let me finish that myself. Okay, trust me, that would have been really painful to watch me type all that. But yeah, this is all the 36 possible ways that any one of the 6 possibilities can go with any one of the 6 possibilities on the first die can go with any one of the 6 possibilities on the other die. Let me copy paste this into the next page. Okay, once we're armed with this little diagram of the sample space, we can answer just about, and this happens with any sample space, once you have it listed out, you can answer just about any one of these questions they throw at you. Like this, what's the probability we're going to find doubles? Okay, it's out of 36, but the doubles you can see land right here, and it's kind of easy to count them once we have that. So this is simply going to be out of our 36, we see above in the highlighted zone I just had, there's 6 out of 36, so it's the same thing as 1 out of 6. Okay, fine. There's other ways to think about that, but once you have the sample space, I think it's really easy to just kind of demonstrate that is 1 out of 6. Find the total on the die is at least 10. Okay, so again, out of these 36 possibilities, how many of these are at least 10? Well, that's at least 10. Whoops, I don't want it to be a cross out. I want it to be a highlight. Thank you. All right, so I'll do this green highlight again. So that's at least 10, that's at least 10, that's at least 10. Notice the sums are on these diagonals. It's kind of nice. At least 10, at least 10, at least 10. All right, I'm running out of time on this segment, so I'm going to stop here. But that was 6 out of the 36. Guess what? Same thing. All right, I will see you in part 2.